controversial puzzle. We see we have between the input and the output the same size of the grid in all cases. So the first thing we do is copy from input. We see that there are in all inputs some blue squares located on the edges, okay, of the grid. In the output, these blue squares are connected with either horizontal or vertical long lines, okay. These long lines are always from opposite edges of the rectangle or the square, okay. They are never within the same edge, okay. But this also depends on the fact that there's never a case in which there are multiple blue squares on the same size, so we don't know for sure if we should connect or not on the same edge, okay. But in all examples they are always on opposite sides, so we connect these opposite sides, and when the line that connects these opposite sides intersects a red rectangle, the whole red rectangle becomes blue, okay. So what we must do clearly in the output is, first of all, we select like this, okay, and we fill these lines, okay. So we don't know for sure if we must connect like this as well, as you can see, okay. But we have at least one more try that we can do. So now from this situation, the only problem that we have is that we don't know for sure if we must color or not this rectangle. In theory, if we interpret literally all the inputs and outputs, there wouldn't be any reason to color it, okay. But in case we must color it, then we just do a second try, okay. So first of all, we color what we know for sure that it's going to be blue, okay. So all of these ones are going to be blue, this one as well. The first attempt we can do is, we think this rectangle does not intersect the line, so we leave it red and we send, and the program says it's wrong, okay, try again. So since it's wrong, we assume this red rectangle should be colored blue, and by coloring blue we see that the solution is correct. The reason this puzzle is controversial is because this red rectangle is not actually intersected, and because we don't actually know if we need to also color here, okay, because there's not a single instance in the given inputs in which there are multiple blue lines, okay. We assume we must not connect, because in all examples the blue lines always connect opposite edges, okay. But in theory that's not sufficient, okay. So this is a bit of a controversial one. There are, in my opinion, multiple valid solutions that must be considered, and most importantly, frankly, most people think that this red rectangle actually should remain red and not blue, because it is not actually intersected. And unfortunately, there's not a single scenario that is similar in the given inputs, okay. So this is why this particular puzzle is a bit controversial.